Welcome to Unchatted Waters. In this episode, we explore marine protected areas, from mapping uncharted areas of the seafloor to understanding how plants and animals use habitats across the globe. So if you're interested in exploring the many threads of information behind that patchwork quilt of MPAs, then join us as we get in the zone. Welcome to Unchatted Waters, the podcast that talks to the people behind the science. I'm Kirsty, your host, and I'm excited to introduce my two guests for today's episode. Alison Pettafor is a seabed scientist, mapping marine protected area data from surveys across the globe to contribute to the science supporting MPA research. Oliver Hogg is a Southern Ocean scientist, researching deep sea environments. His work helps to design effective marine protected areas, from mapping seabed habitats to understanding impacts such as fishing. Welcome to the podcast, both of you.
Thank you. Hello, good to be here.
Great to have you. So my first question is going to be defining a couple of the acronyms we used in the biographies. An MPA. So what is a marine protected area, and why do we need to protect our marine environment?
So a marine protected area, or areas, are areas in the seas and oceans that are managed to ensure the conservation of marine animals and ecosystems, but also as well as allowing sustainable use for the environment. These can be things such as protection from commercial fishing, anchoring, water activities, deep sea mining, or even creating structures. So why are we looking to protect these areas? Some species or features are quite vulnerable and therefore might not be able to recover from these potential threats and risks, or they even might need intervention to be able to recover.
Ollie, where did MPAs or marine protected areas originate?
I guess it's important to say that some form of marine protection of the world's oceans has been in place for probably at least a century. But
Wow.
the idea of an MPA, as outlined by Alison, really traces its roots back to 1962. So we think 1962, Cuban Missile Crisis, Nelson Mandela had just gone to prison, the year that the personal computer was first talked about. But there was also a little known meeting in Seattle, World Congress of National Parks, where they started discussing how best to protect the world's oceans. But nothing happened immediately. And really we have to go then to 1975, where we saw the establishment of a couple of very different marine protected areas. So firstly, we had the USS Monitor protected area off the coast of North Carolina in the US. And this was actually protecting a Civil War era shipwreck. So that's actually a different kind of reason for protection, sort of cultural and historical reasons. So you had that one example, which was actually a very small scale. I think it was only really a couple of square kilometres. And on the other end of the scale, you also had the Great Barrier Reef Marine Park, which covered almost a third of 1 million square kilometres. So they're two examples of the first marine protected areas as we know them. You might think we came quite late to the party in the marine environment. You know, in the terrestrial environment, national parks had been in place for well over a century. So you have places like Yellowstone in the US, which is 19th century. And I think one of the reasons for that is that the oceans were seen as this sort of limitless resource, this vast environment that we could just keep on taking things out of, and it would just replenish itself. And that view is starting to change at this point. You know, fish stocks, for example, have been depleted and is changing our view of the oceans. And so there's then a series of meetings through the 1980s and 1990s. We had the UN Convention of the Law of the Sea, which established the definition of EEZs, which is economic exclusive zones. And this is this normally 200 nautical mile zone around countries. And that gave individual countries the rights to look after the living and non-living resources within their marine environment. And it also enabled them to start thinking about how to unilaterally decide how to protect them. And then moving into the 1990s, you had the Rio Earth Summit, which first introduced a target of 10%. We want to protect 10% of the world's oceans. Okay. Again, nothing very immediate happened. So in the 2000s, still I think less than 1% of the world's oceans are covered by marine protected areas. But if we wind that forward to now, we've seen over the last 20 years about a tenfold increase in the amount of space that's protected as marine protected areas. Where are those marine protected areas? They're all over the globe, so from the icy waters of the Antarctic all the way through to tropical seas. Most of the area is really centred around some very large marine protected areas. So of the 10 largest marine protected areas globally, that sort of encompasses 60% of the total area that we protect. There's a lot of smaller ones, so 11% of the area of marine protected areas falls into 18,000 much smaller marine protected areas. So there's a complete mix of different sizes and different types of marine protected area.
Wow, okay, so that was like a real history lesson and lots of information there. I'm just going to break down a bit of it. So when you talk about the different sizes of marine protected areas that exist, is that as a bird's eye view, that area and that geographical area, or is it in terms of depths that are being protected?
Yeah, no, that's a really good question, because actually it's a question that I got asked by a marine manager for one of the marine protected areas that I'm sort of working with in the Southern Ocean. So when we talk about area, we're looking at a sort of bird's eye view, so the actual area of the surface of the ocean rather than the sort of 3D picture. But the question I was asked is, what is the sort of volume of our marine protected area, which is actually a really complicated question to try and map the seabed, and maybe we'll come on to talking about some of that later.
Brilliant. Well, thank you so much for that info. It's nice to go back in time and see what originated these ideas to protect the marine environment. So like Ollie was saying, when we look out at the sea and the previous opinions of something maybe that we don't associate with quite as easily, we can't see what's underneath the surface, how can you start to understand whether an area or a species needs to be protected in the marine environment, Alison?
It's predominantly a science-led. So you're looking at sort of how to understand your environment. So the first thing you need to do really is gather as much evidence as you can. When we're looking at different areas in the seas and oceans, you really need to consider what is sort of available already, not just a UK-wide, but there's also a global network for different types of data that is available, and also within different organisations. So whether you've got actual maps of the seabed, whether you've got camera data available, any local data. Actually, if you're speaking to different countries, you might have like fish catch data. Some of the good resources are actually data from divers, because they're actually going physically into the environment and are looking around, even closer at things that we might not be able to naturally. The more useful things I find is also talking to people, people that get going out, people like fishermen that are going out on vessels all the time, and, they know the fishing grounds, their fishing grounds are at the back of their hand. So using that as a resource as well is actually really interesting.
Is it fair as an analogy to say that you're layering up your scientific evidence? So first you map the seafloor at the bottom, then you understand maybe the animals that are moving around the area from your fishing data, then from that you're thinking about a diver's perspective, which is seeing both the substrate and the fish, and then thinking about the external factors like maybe the surrounding area on the surface. Would you say that it's layering of that scientific evidence that you're kind of contributing to get that full picture?
I think some of it is, and I would use the map as a place to start, because when you're looking at what information you've got and what you want to know about the area, you might use that map to determine what else you want to look at. So you might see a feature of interest that you might want to put a camera down next to, or you might say, okay, we were going to do some fishing here to see what the species are, but actually the ground isn't good enough to put out the fishing nets. So you're starting at the seafloor and you're making your way up through the columns. So you might take some oceanographic data, so the temperature and salinity might also give you a lot of information about the environment. If you're collecting repeat over time as well, then you can track the changes to the environment, and again how that is impacting like the seafloor or the species, whether you see a decline in a certain type of species or whether you see more damage to the environment. It's similar to what you'd see with sort of sea temperature rise in coral reefs, and that after when it gets too warm you might see a decline in the species, or it might die off bits of coral. It's a similar sort of that you'd look at what information you've got and decide to collect more data to support your evidence in that area. Okay,
so even though, like I was talking to Ollie about, that it's a bird's eye view of an area, actually all those layers of information that's in your scientific evidence is not really shown on the map, but it's all there underneath, a bit like the environment underneath the surface. It's all there, worked out, and how it all interacts is creating that kind of full picture.
Yes, it's actually been quite interesting and amusing in some of the areas, because the areas, if you were to look at, for example, the UK marine protected areas, they are lots of weird and wonderful shapes. And there's a bit here and a bit there. And when we were trying to get some of the initial data, we had some data, but you'd have a box, but a bit cut out in the middle, because we had the information in the middle. But trying to get more data, and people are wondering, why have they cut out the middle of the box? But obviously we had some data there. So it became quite a talking point where people are like, why have we been sending these really weird areas to survey? But it is based on the data that we found, and it is based on the information. And yeah, as you said, all these layers.
So it's like a patchwork quilt of knowledge as well that you're adding to and surveying and finding more information. And you might have the ball of yarn for some areas, and you might have done that little central bit first, but you need to build up the rest. That's what I think when I see a marine protected area map, is it's like a really nice patchwork quilt of knowledge and information and evidence that's been gathered. And
I'm interested in the relationship between the environment, the physical environment, and the animals that live within it. So I'll gratefully take Alison's data sets. I'll take all of those different data layers, try to understand how biodiversity in the world's oceans is structured spatially. How we do that, for example, if I'm looking at establishing a marine protected area, perhaps one factor that I might consider is hotspots of biodiversity, and where to understand and decide where those hotspots are. And really, how we survey the ocean in many respects hasn't changed very much in a century. We put a net on the end of a long cable that goes sometimes kilometres down to the seabed and take physical samples. And it's in many ways a really inaccurate and
ad
sort
hoc,
of,
maybe.
way of sampling the environment. I mean, if you want to take a sort of dubious analogy, perhaps it's a bit like me going up in a hot air balloon above here in Lowestoft where we're sitting, and sort of throwing over a grappling hook or throwing over a net and sort of dragging it along the environment around Lowestoft. And that net will sort of jump around and it will collect some things, it will miss a load of other things. Some things will fall off as I pull my net back up. And so really it's just giving us these sort of little snapshots of what's happening on the seabed.
So is that why you need to have kind of that collaboration between the two different work areas to make sure that you can substitute what the grappling hooks missed with different levels of technology and different approaches?
Absolutely. So adding to our understanding of the marine environment by sort of introducing new technologies. So we've been using across marine protected areas around the world, so putting quite high-tech camera systems down onto the seabed. And this gives us a more 21st century, if you like, view of the world's oceans. We can use that information. It still only gives us these sort of little snapshots of the seabed, but what we can do is take the kind of data that Alison's talking about, so those seabed maps. We can take environmental data sets such as, oceanographic currents and temperature and things like that, and start to understand what conditions certain animals like to live in. And we can use our understanding of that, those kind of environmental envelopes that certain species live in, and model that across a much larger area. And that helps us understand and underpin some of those marine protected area designation decisions, so where we're putting the marine protected areas and how best to protect marine biodiversity.
Wow, it's a really nice image to imagine you up in a hot air balloon. It's quite a romantic image of, analogue going around the world in a hot air balloon. And I can certainly imagine you putting a camera over your hot air balloon is probably much easier than putting a grappling hook over. One thing I just wanted to clarify with you in terms of your analogy, I'm assuming you're not putting a camera on the seafloor that's then moving around and exploring the environment. Can you maybe delve a little more in painting a picture to what that camera work actually kind of looks like?
So sometimes we'll use remotely operated vehicles. These are still tethered to a research ship above, but have a pilot that will fly that remotely operated vehicle across the seabed, so you can do sort of transects.
So what do you mean by a transect?
A transect is simply a line across the seabed in which we'll try to capture information by taking images and taking video footage. So look at a much larger area across the seabed and actually control it and go where you want to investigate. We also use fishing vessels as platforms of opportunity. For a lot of marine protected areas around the world, they're very remote, they're expensive to get to, it's logistically difficult to do science there. But if you have fishing vessels in the region, why not ask them to deploy some cameras for you? So they're more simple cameras, they just attach to the fishing gear, and it gives you an idea again of what's happening on the seabed and what interactions the fishing gear is having with the seabed. And we also use camera lander systems. So again, still attached to a research vessel. Again, you can do transects and look at a larger area of the seabed.
So Alison, I just wanted to go back to you a moment and talk about some of the mapping. I think what Ollie did there was describe understanding the animals in the living environment. So can you go through an example of how you map the seabed as that first stage of the process?
So predominantly we'll be using a multi-beam echo sounder.
A multi-beam echo sounder.
A multi-beam echo sounder basically is a piece of equipment which sends down sound waves which bounce off the seabed and return, so you can get nearshore well-defined data, but then you get ones that can go quite far and quite deep, so you can go down to thousands of meters.
So that multi-beam, I guess that's the bit I haven't heard of before, is that, I'm imagining, on a film where you have a bank heist and there's one of those kind of laser security systems that's got kind of fronds of lasers kind of scanning the door to make sure no one's coming through. Would you say that's a good analogy to how the multi-beam works? It's looking at the area and then mapping in 3D what's occurring on the seafloor, or
so,
I maybe oversimplified it a little bit.
So they don't move, they will point in the direction you want it to point in, so it can either be at an angle or it can be straight down, and then you can have it angled out to however many degrees you need to for the bit of work, and then it sends down multiple beams, so say like 500 beams.
500 beams?
Yeah.
Whoa.
And
so like a row of 500, or is it like 500 kind of pulses?
Well, you can choose whether it's at an angular difference or whether a certain distance on the seabed.
So it gives you a better picture because it's got so many beams kind of going down.
Yeah, and it's constant as well, so you're getting like so many pings all the time.
Wow. What does it look like on the screen once you get those pings back? Does it like create an image for you in real time, or?
There's different parts of the screen. You can have just a cross section literally, which is a snapshot in time, or you can have a section which gives you an area, and as you go over it, it will update and you can see the update on the screen. So for example, if you were going over a wreck on the screen, you'd see the whole wreck as it was coming through, and then the snapshot will show you the different levels of the wreck as you go over it.
Wow. That must be quite exciting when you're on the boat and you start to see something coming on the screen that maybe you weren't expecting, or...
Well, actually, data gathering is probably one of my favourite subjects. But so I went on a survey between the Falklands and Tristan da Cunha. I did actually get up early, which is probably quite sad. But I got up early to see us going over the Mid-Atlantic Ridge and captured that in real time. And then I sent everyone on the vessel a snapshot of what the data looked like as we went over it.
Oh, wow.
But
so everyone goes mad about crossing the equator, but that sounds pretty... I think you got up for a good reason.
I was one of two people that got up. So the other thing that you can tell by the data return is the intensity of the return, which also gives you an idea of what type of seabed you're looking at as well, whether it's like sandy or rock. So you get 2 bits of information from one system, which is a good basis because you have your depths and then hopefully the type of surface that you're looking at, which can then start to feed into those areas of interest. One of the really interesting features that I was lucky enough to look at was some seamounts, both around Tristan da Cunha and St Helena. We had some information, the seamount that we were looking at, but when we started to go up to the seamount, it was evident that it was far different from what we were expecting. And we had actually spoken to some of the fishermen, and they were saying that they were fishing at a certain part which didn't match up again with the general information we already had available. So while we were there, we said to drive straight at the seamount until we reach the contours that we expect we should be reaching, and we could define where the actual top of the seamount was. By doing that, we then could go around the top of the seamount, and it was completely different to the data that we'd had previously available. And there was, to the point where it was like over 1,000 meters different in some places. The most accurate data was actually from the fishermen and their information and where they'd been fishing. Disproving the previous data that we had, we could then define the new environment.
You know, like, I'm imagining Ollie in his hot air balloon again, but it's almost like just as exciting that you're going across water that you've heard a rumour about, go and you find something completely new. It must be really exciting.
Yeah, definitely. And I mean, some of these seamounts are absolutely massive. To sort of put it into a bit of comparison, there are some like the same size as Ben Nevis. So, and that's what you're going out and you're mapping these vast areas.
The story that Alison's just told is really commonplace for a lot of the marine protected areas around the world. Like I mentioned earlier, you have 60% of the area protected by marine protected areas within the 10 largest marine protected areas in the world. A lot of those marine protected areas are in really remote regions, so around oceanic islands. And the majority of the environments around those islands are deep sea. They're regions that we really know very, very little about. And so when we go there on discovery expeditions, on surveys, I share your enthusiasm actually for the bathymetry, because that's often the first thing that you go and collect. It's that mapping of the seabed, and it's that voyage of the unknown, isn't it? It's sort of, you don't know what you're going to find.
No, and it's just fascinating. And as I said, it's even more interesting when you disprove something. And next to that seamount, it showed 2 separate seamounts, but it was all part of a connected one. And again, we wouldn't have known that without doing that trip.
And it's almost like uncharted waters, which I think is quite nice on a podcast called Unchatted Waters. So, you know, you're going out to something that's not been mapped before and you're mapping it, and you're just the first person to see what's going on underneath the water, which it sounds incredible. It sounds really interesting. Well, thanks for taking me on that journey of discovery. That was really, really fun. I just want to think about where we should be protecting marine environments. So we've talked about some examples of seamounts being important habitats, needing to map those. So as the ocean's such a big place, where should we be protecting marine environments across the globe, Ollie?
Can I have an easier question?
I'm afraid not. I asked the stupid questions, the simple questions, the good questions, and the hard questions. So
yeah, I mean, fundamentally, that's a difficult question to answer. It's the careers of many marine scientists, marine managers, policymakers around the world try and grapple with answering that question, right? You could say close it all, close the world's oceans, but fundamentally we rely on the world's oceans for food, we rely on it for transport, we rely on it for our pleasure and tourism. So there needs to be a means by which you prioritise which parts of the ocean to protect and which not. And how you do that depends on what you're trying to protect, and also what data that you have to support decision making. We've discussed the physical environment. So you could look to protect physical features, such as a seamount, such as canyons, such as sort of deep sea hydrothermal vents, those kind of interesting environments, either for their intrinsic value, but also because potentially they're useful proxies. So if we, for example, think back to the seamount example, a seamount in the middle of the ocean changes the oceanographic currents around it. Perhaps it creates an upwelling of currents around the seamount, and this brings nutrients to the water, to the surface waters.
Sorry, the jargon alarm's gone up. Can you describe upwelling in a bit more detail?
So an upwards movement of water, so where an oceanographic current would hit a physical obstacle, in this it's sort of pushed up towards the surface water and bring nutrients up to the surface, and this can start a chain reaction, if you like, where you have rich phytoplankton in the water and animals that eat that, and then the fish that eat that, and you start developing a sort of rich and unique ecosystem. So that's an example where a physical feature of the ocean could be important to protect, because you think, even if you don't know, you think that it might support rich marine life.
So when you talk about the proxy, you're understanding the kind of processes that these physical features could encourage. So you're assuming that in places where those physical features exist, it is happening.
Yes, yeah, precisely. Likewise, you might also be interested in specific species. So perhaps a species is particularly rare, perhaps it's endemic, it only occurs in that one place, and so it's important to protect that. You might want to protect commercially valuable species, for example, certain fish species. You might want to protect charismatic species or culturally important species, sort of charismatic megafauna, whales, dolphins, penguins, whatever it might be. And there's also the species and the habitats that offer humans key ecosystem services. fish habitats, for example, nursery grounds for young fish. You might want to protect those to make sure that you have a healthy population of adult fish.
So you can eat them, right, for that service?
Yes.
It's like a food service.
Like a food service,
Okay.
yes. Threatened species, or habitats that are particularly vulnerable to impact. Finally, an important word that crops up again and again when you talk about marine protected areas is representativeness. So that comes from the Convention of Biological Diversity. This is sort of embedded in that legislation that a lot of nations have signed up to commit to protecting 10, or it's now moved to 30% of the world's oceans. But they want the protection to be representative. And when we talk about representativeness, what we mean is, for example, we might want to protect coral reefs because coral reefs are, important, diverse and vibrant marine ecosystems. But we don't just want to protect coral reefs. We want to protect all sorts of other habitats as well. So you just got to make sure that the areas of the ocean that you're protecting cover a cross-section of different types of environment and not just one.
Okay, so we've been through quite a lot of things already. We've talked about what a marine protected environment might be, where they might go, things about making sure it's representative. So once we've decided all those layers of data and we set up a marine protected area, is that it? Is it sorted? Can you give yourself a gold star and it's done?
I think that would be the dream.
That sounds wonderful.
Yeah,
but
it does. Nice, doesn't it?
I think it's not just the animals themselves that have the life cycles. It's the MPA goes through a life cycle as well. So look, the ocean's a dynamic place. Once you put your protection measures in place, the environment and the habitats within it change over time, and that change might be environmental change, it might be as a result of changes in our climate, but it might also be as a result of the management actions you put in place as part of the marine protected area. So as time goes on, some objectives might be achieved and new objectives may emerge. It's important to have a review process. So typically an MPA goes through 4 different stages. It goes through its initial design, and then you implement your marine protected area, pass it into law, and it sort of comes into force. And then it goes through, hopefully, a research and monitoring process where you're collecting more data and improving your understanding of that environment. And then finally, it goes into a review and an update phase. Things are always changing. Right. So not only is the world changing, but also our understanding of the world is changing. As we explore more and collect more data, that changes our perception or our understanding of our impacts on the world's oceans.
As science has always been, we're always trying to improve our knowledge, understand more about the world. We're always striving to do that, and I think that's never going to stop. It's happened for hundreds of years, and it's something that we're continually being able to expand. And the way I feel is that my work's never going to be done, and that's what makes it so exciting. It's because we're always going to be finding new things and learning more and improving our knowledge base, and then improving that knowledge base across the world. So is it a one-size-fits-all?
A marine protected area is just one example of how you can do conservation within an area. But I think it's within MPAs there isn't even one definition that fits all. You've got special areas of conservation, marine conservation zones, sites of special scientific interest, and a few more. But these might be specifically about an area or a specific habitat. It's like one of the tools basically that you can use, and you might want to specify it a bit more into what you're doing within that area. Definitely one size doesn't fit all with MPAs, but if you've got the right people looking at the right sets of data, you can achieve so much more in one MPA than you might be if you just go out to do one part of it yourself.
And lots of different input from scientists from around the world. And I think that's key to the future of MPA research. Many nations in the world have signed up to something called 30 by 30. So this is to protect 30% of the world's oceans by 2030. And in order to achieve that, look, we're going to have to start thinking about protecting waters that transcend national boundaries, working with different nations to try and get a network together that goes across borders. There's precedent for that. The largest marine protected area in the world currently is in Antarctica. So it was an international agreement to put this together. it shows that it can happen, it shows that it can work, but it's not easy because you have a lot of people around the table that have just got different viewpoints. And so bridging those kind of divides is going to be a key challenge in the future.
And I think the way you've described it kind of inspires me to learn more about it, and hopefully others that are listening to learn more about the complexities of our natural world and how we can better protect it. So I think it's time now to move on to our fun fact feature. So this is our kind of nugget of information or fun fact somebody could take away to a party as a conversational opener about what they've learnt today. And I think, Alison, I'd like to go to you first for your fun fact, please.
So my fun fact is about Seabed 2030. Basically, all around the world, trying to create and put together all the different bathymetric data sets to basically create an entire map of the world's oceans by 2030.
An entire map?
Yeah.
Wow. Would that include kind of going over the entire ocean? Or?
So it's a combination of things. I think they are trying to map basically as much as possible, and our data sets are also being used to feed into that website dedicated to Seabed 2030.
It's going to be really interesting to see how that unfolds.
Yeah, definitely.
Right, Ollie, it's time for your fun fact.
Okay, so if today's conversation has given you an appetite to explore more about MPAs, then there are games that you can do online. So if you go and search online, you can find interactive games where you can design your own marine protected area. Oh, wow. So you can input lots of the data sets we've been talking about today and understand how your decisions of how a marine protected area might work impact the ecosystems, how it might conserve ecosystems, or have sort of unintended consequences, if you like. You sort of put protection in one area and it might have an effect somewhere else. So that's really cool and really interesting to try out.
With real data? Wow. That sounds really interesting.
That is pretty cool.
I mean, I would be really into video games if they'd been more marine based. That's brilliant. So it's the end of the episode now, which I'm quite sad about because it's been so interesting. I think from where we started at the beginning of the episode, talking about that patchwork of information and all the layering that we do, I guess my final question would be, where are we now? How far along with that journey have we got to? What does our patchwork quilt look like at the moment in the UK?
So in the UK, as of November 2018, there are 314 designated MPAs protecting 24% of UK waters. And just to give you a comparison, in 2012, we only had 217 sites, which only covered 8%. So we've increased by 16% in the last 6 years.
That's really nice to finish on. So I'd like to thank you for your time today. As I said, it's been really interesting and I've really enjoyed unpicking the layers of that map and how marine protected areas work. So thank you.
Thank you.
Thank you.
Thank you for listening. This podcast was made by CFAS, the Centre for Environment, Fisheries and Aquaculture Science. To keep up to date with us, follow us on social media using @CEFASGovUK. We hope you can join us again next time.